Hello everyone and welcome back to my channel. In today's video, I will be introducing you my new fruit classification model that I have made using Python, and it is powered by AI and machine learning. So let's get into this project right away. This is the project. Now I will be presenting my presentation and it will load in a second. Here we are, the fruit classification model presentation. And this is a table of contents. So firstly, I will be giving you an introduction about this project. Then I'll be talking to you about a data set, then about the model training, the GUI, and then the conclusion and future of this project. Moving on to the next slide is the introduction. So this is a fruit and vegetable classifier, and that's a machine learning solution trained to identify various fruits and vegetables from images. This presentation explores its dataset, model architecture, and user-friendly interface for seamless classification. Moving on to the next slide is the dataset overview. So a comprehensive look at the dataset comprising 22,495 images categorized into 33 classes of fruits and vegetables. It includes insights into the training and test set sizes, image dimensions, and file naming conventions. Moving on to the next slide is about the model training. So data preprocessing. So I prepared a dataset by scaling, augmenting, and organizing images for effective model training. And for the model architecture, I've designed and configured the neural network architecture, leveraging techniques like convolutional and pooling layers to learn hierarchical features from the images. And model training continued. So I have utilized libraries like NumPy, Pale, and keras.preprocessing.image for image processing and data manipulation. Then I have implemented data augmentation using image data generator from Keras to make variation of training images. And I've employed transfer learning by freezing the pre-trained layers to extract useful feature from fruit and vegetable images. And I've leveraged the pre-trained VGG16 architecture available in keras.application.vgg16, which is initialized with ImageNet weights. Moving on to the next slide is about the graphical user interface. So I have a file browser which allows users to select an image for the classification, and I have implemented it using kinter.filedog as open file name to open a file dialog window. Then I have given an image display thing which displays the selected image for the classification. Then I have given the result label. So I've implemented it using kinter.label to show the classification result text, and I've given a background to the window to make it look good. So for the conclusion, in conclusion, this project successfully developed a fruit classifier system using deep learning techniques, and the model was trained on a dataset consisting of 33 classes of fruits and vegetables, achieving impressive accuracy levels. The validation accuracy was 99%, which is the accuracy on the unseen data. So it's a very good accuracy. And for future directions, I can optimize my model. I can fine tune it to get even more accuracy. And for data expansion, I can gather more diverse images and classes to enhance the data richness. I can deploy it in checkout systems and smart fridges, and I can also add features like image preprocessing or augmentation in the GUI, within the GUI. And to end the presentation, I have a quote which is, "Be like a pineapple, stand tall, be sweet, and always wear a crown." This is an anonymous quote, but I found it cool. So thank you for going through the presentation with me. Now I will show you my project in Python, in PyCharm. So here is the training model code. Also, I will be adding the GitHub under my video in the description, so you can always see it from there. And so here I have firstly imported the Keras model to build a neural network. Then I have set the path to the directory containing the training set. I have imported image data generator from Keras for data augmentation, created an image data generator object, and then I've generated training and validation data. And then I've imported VGG16 model architecture, loaded the model and the pre-trained weights, froze the weights, and then added fully connected layers on top of the base. I've outputted the layer, created the final model, displayed the summary and model architecture, compiled the model with categorical cross entropy loss and atom optimizer, trained the model using augmented training data and validating on validation data, and I've saved the model for future use. And this is my GUI. So I have firstly imported Kinter for the GUI, and I have also imported NumPy for numerical operations, and Keras for loading the model, and plist for the image processing. Then I've loaded a trained model, defined the fruit classes, given a function to pre-process the image, function to classify the image, function to handle the browse button click event. Then I've created the main window, set the window dimensions, loaded and resized the background image, created a button for browsing the images, created a label for displaying the result, and then started the GUI using root.main loop. Here I've run the project already from before because it did take some time to load. So I wanted to run it from prior time. So here we have some images of Apple Braeburn. So let's go ahead with one of the images, and it should give the prediction soon enough. It's taking a little bit of time. Here we are, Apple Braeburn. Now we have more files. Let's go with pomegranates, which also looks like apples. So we can see if it can differentiate. Yeah, obviously it can. And let's go with something like a clementine. Yeah. We can also go with oranges, because oranges and clementines look pretty much similar, but not the same because they are more brighter. Yeah. We have the predicted class orange. Then we can go with plum. There we go, we have plum. And let's go with pineapples, like the background. There we go, we have pineapple. So we can see that the prediction is pretty much accurate. All of them were accurate, and it's working well. And this is what was my project about, and I hope you enjoyed the video. If you liked the video, please give a like and subscribe to the channel. I'm trying to reach 200 subscribers, and your support, without your support, it's not possible. So I look forward to catch you in my next video, and I hope you have a great day.